Movement data are complex. They capture different behaviors that are exhibited by the moving individual that was tracked. In order to identify different behaviors that are captured in the trajectories, we can use trajectory segmentation. Trajectory segmentation is a useful technique in analyzing animal movement data. In machine learning, the primary goal of segmentation is to decompose complex data into segments of similar characteristics. It is often applied as the first step in a machine learning process, facilitating further analysis and pattern discovery. In movement analysis, it is applied to identify behavioral modes that are presented in the data. And then, using segmentation, you can convert movement data to a simple structure as a sequence of various behaviors. In movement ecology, trajectory segmentation can be applied, for example, to identify different phases in the migrations of animals, or to detect behaviors such as foraging, hunting, and resting. Trajectory segmentation is the process of dividing a continuous movement path into distinct segments, each characterized by a homogeneous pattern that represents a specific behavior. The goal is to identify natural breakpoints where the animal's behavior changes significantly. The change in animal behavior can be identified by changes in its movement parameters. For example, any change in speed, acceleration, or direction of movement can represent a change in behavior. Trajectory segmentation involves multiple processes. Here is how we do it. First, we pre-process trajectory data to ensure data quality and remove errors and outliers from the trajectories. For example, we remove points that are located outside the study area. Once the data is cleaned of obvious errors, we compute movement parameters such as step length, speed, and turn angle. By evaluating the distributions of the computed movement parameters, we can further identify potential outliers and remove them from the dataset. For example, we can remove GPS points with unusually high speeds that are not reasonable for the animal that we are studying. Next, we can use these movement parameters to characterize animal movement at each timestamp. Using them, we identify relevant features for each behavior. For example, resting behavior can be identified by stops or points at zero or very low speeds. Migration flights exhibit higher speeds and a directional movement with lower turn angle values. Foraging represents points with variable speeds that might exhibit more changes in movement direction to search for food. One way to identify distinct behaviors is to extract change points in movement parameters along the trajectories. If we record a movement parameter such as speed over time, we then will have a time series of speed values. We call this a movement parameter profile. Then we can use this to identify variations in this profile based on how much the values deviate from a baseline, for example, from 0 or from the average of speed values. A set of thresholds can be used to characterize behavior using speed values to near zero speeds, or points with low speeds, or points at high speed values. Or we can use turn angle over a time period to identify points that are directional versus more of a search movement pattern. Once a trajectory is marked with change points, different behaviors are interpreted. This is often conducted with the help of domain experts or by using ancillary data such as direct field observations. For example, points with zero speed can identify stops or resting locations. Points with low speed identify foraging or search. And high speed points identify migration or flights. Similarly, changes in direction using turn angle can be utilized to identify a sequence of points with low turn angles, representing directional or migratory flights, and sequences of points with variable turn angles can identify search or foraging. After the identification and extraction of different behaviors, the trajectories are then converted to a sequence of different behaviors with their associated labels for further analysis. By segmenting trajectories and detecting behavioral modes, researchers can analyze behavioral patterns over time and gain a deeper understanding of animal habitat use or migration strategies. Then by correlating these patterns with the environment, we can investigate the underlying ecological processes driving animal behavior and their responses to environmental changes.